Welcome to another episode of Software Explorations, Concepts and Overviews, hosted by your truly tech coach, Ralph. In today's episode, we're going to be talking about Jenkins. So 2 weeks ago, we spoke about CI/CD, and then we spoke about some of the CI/CD tools such as Jenkins. So I wanted to speak more about Jenkins because that was like the first CI/CD tool that I truly used, truly learned, and I think it's the most popular CI/CD tool that is still out there. It is open source, so anyone can get started on it to start learning. And then I think if you have a decent understanding of Jenkins, then you can easily start to understand all of the other more commercial, more enterprise level CI/CD tools. But trust me, many large companies still use Jenkins to a certain extent, depending on what they need done. All right. So I think that knowing Jenkins is still one of the most popular tools that is needed for you to be successful in the tech industry. All right. So with that being said, we are going to get into it, but do me a favor first, like the video, share the video, subscribe to the channel, hit the notification bell so you can know every time that we go live, and go to techcoachralph.dev, sign up for the Patreon, sign up for coaching one-on-one. We can work together. I have a lot of goals that we are working on for the second half of this year, including helping you guys level up in the tech field. So if you want to work with me one-on-one, build some experience, have your resume right, have your interview skills right, then go to techcoachralph.dev where we will run it up together. All right. So with that being said, let's jump into it. Let's get into our introduction to Jenkins. To me, it's the most popular CI/CD tool ever. And this is part one because we're going to have multiple parts to this video. This is a pretty intensive and extensive application for CI/CD. So we're going to break it up a little bit. All right, let's get into it. So what is our agenda for today? Our agenda is we're going to have a recap of the CI/CD pipeline. We're going to be talking about what is Jenkins. We're going to be going over the architecture of Jenkins. We're going to be talking about how to set up Jenkins. We're also going to be going over the Jenkins UI, the pipelines, and we're going to be talking about version control in Jenkins and then automated builds. Then we'll wrap it up there for this part one of it. And then next week we'll get into part two and we'll continue with everything else about Jenkins. All right. So let's get into it. So what is CI/CD? This is a recap. We talked about CI/CD pipelines about 2 weeks ago, and we're gonna do a quick recap, so a refresher. Okay. So it's a set of practices in software development where code changes are automatically built, tested, and deployed to production. This process ensures faster and more reliable releases, allowing developers to detect and fix issues early and frequently. CI/CD is crucial for maintaining code quality, reducing manual errors, and accelerating the overall development cycle. So, and the thought about continuous integration, continuous deployment, that's what CI/CD stands for, is that as you merge code, there's a series of checks that's going to be happening. It's going to build the code, then it's going to run these tests. And then if everything passes, then it's going to push it it's going to merge it into your main or master branch, and then it's going to deploy it to production as well. So it takes out a lot of manual issues. I remember back in the days when I was deploying software, it was such a manual, tedious process. I have to go to a bunch of servers. CI/CD is supposed to alleviate all of that, where you don't have to do a bunch of manual things where there can be so many different errors happening. So Jenkins at your service. If you notice, the logo for Jenkins is a butler, right? And it's supposed to help facilitate, make things a lot easier. So Jenkins at your service. Did you call? And yes, we did. We need some help. We need you to help us make this easier, right? And like I said, Jenkins, the most popular one. It's open source, so anyone can install it, pick it up, and go from there. So what exactly is Jenkins? Jenkins is an open source automation server used to implement continuous integration and continuous delivery CI/CD pipelines. It automates the building, testing, and deploying software, enabling developers to detect and resolve issues early and often. So by these checks, these series of tests running over and over and over again, every time we merge, every time we push code, it's supposed to let us know right away if there's any issues. And if there are, then it doesn't deploy, and we can go and investigate those, fix them, push them back up. Those whole series of tests run over again. And this is what makes automation so important and integral to the development process. A lot of people they say, oh, manual testing. But with manual testing alone, we are not able to successfully do the CI/CD process. Jenkins is highly extensible with a vast library of plugins that integrate with various tools and platforms. So what about the Jenkins architecture? So it consists of a master slave, now called the controller agent model. The Jenkins master, the controller, manages the orchestration of job scheduling, dispatching builds to agents, and monitoring their progress, as well as presenting the build results. It also provides a web UI and interfaces with version control systems. So pretty much it has a hub, which is going to be your master or your controller, and then it has slaves or agents who work who do the actual work, right? And then there's a user interface that you can navigate to that makes it easy to get things done. Continuing, so Jenkins agents, the slaves, are responsible for executing build tasks assigned by the master, the controller, allowing for distributed and parallel processing to handle multiple projects simultaneously. Agents can dynamically be provisioned and scaled based on workload requirements, often using cloud-based architecture. So in cloud architecture, you can say, all right, this is if we get to this threshold or we have this many jobs running, then we need to add an additional server, which would be an additional agent to make it bigger. So you have a threshold, and then you scale based on that. So as the number of jobs decrease, then you're going to close or shut down those additional servers that are running those agents. Communication between the master and agents typically happen over secure channels, ensuring reliable and secure execution of build tasks. Now, how do we put this all? How do we assemble it? How do we put it all together? So how do you set up Jenkins, right? Setting up Jenkins involves first installing the Jenkins server on a machine, which can be done via packages for various operating systems, Docker containers, or from a standalone WAR file. So we're going to be doing this together in a couple of different ways. We're going to be doing this using Docker on a AWS EC2 instance, where we can install Jenkins and we can get it set up. We can access it on the web. And then we're also going to be doing it locally using Docker. To me, Docker is like you can always install it directly on the server, but to me, installing it through Docker has always been the easiest way for me because it makes it easy to update, things like that. So we're going to be focused on Docker, but we're going to do it on EC2. We're going to be doing it on locally. Maybe just maybe we might try it also in other platforms, maybe Azure, maybe in Google Cloud Platform. We'll see. I'm not too familiar with Azure and Google Cloud Platform yet, but it would be a cool thing to figure out how we can get those servers running in those environments. So once installed, you configure Jenkins through its web interface, setting up the initial administrator account and securing the instance with proper authentication and authorization mechanisms. You then install necessary plugins to extend Jenkins functionality, integrating with version control systems, build tools, and deployment platforms. There are so many different plugins that makes it so much easier to be able to use Jenkins and to make your CI/CD pipeline run well. Configuring the build environment involves setting up agents either on the same machine or on remote systems to handle the execution of jobs. So if you don't have like a lot of different jobs running, a lot of heavy jobs running, then you can probably get away with running those agents on the same machine. But if you have a very extensive workflow, it's like as you grow, then you're going to have to expand. So you might have to end up setting up agents on those remote systems, and those remote systems would be other servers, other cloud servers and things like that. You then create and configure your Jenkins jobs or pipelines, defining the steps for building, testing, and deploying your projects. Regular maintenance and updates ensure that Jenkins and its plugins stay secure and functional, adapting to evolving project needs and infrastructure changes. So if you remember, we had a video, the Bug Bite, where it was just last week, where we were talking about how 75% of vulnerabilities are exploited within the first 19 days. So it is crucial that we do regular maintenance and updates on our Jenkins server so that we do not fall victim to these cybersecurity attacks. So what about the Jenkins UI? A web-based interface that allows users to configure, monitor, and manage their CI/CD pipelines. It provides a dashboard view with access to job statuses, build histories, and configuration options, making it easy to visualize and manage project workflows. The interface also supports various plugins that enhances its functionality, offering additional views, reporting tools, and integration capabilities. So I think that's pretty cool. One thing that we can also do is that a plugin that I used at a former job was that on my drive into the office, I could kick off the automation tools. I was able to install a responsive template for Jenkins, and that way I could navigate on my phone, kick off the job, and then head to the office. And by the time that I got there, I would have the results waiting for me instead of getting there, wasting like an hour waiting for all these different tests to run. So I was able to kick it off on my drive to work. So this is an example of how the Jenkins interface looks. It pretty much has let me go this way. It has like you can create a new item, you can set up users, the build history for any particular builds that ran. This is the manage Jenkins where you can configure your settings, add new pipelines, connect to Git. The credentials, like so usernames and passwords, and the different views that you might have. And here it has like you can go into build your project. One of the things that I did was I built the project with parameters, so I can pass in different parameters to get different test results. You can configure your project, what GitHub is supposed to be connecting to, the repo, all that type of stuff, right? So this is what the homepage looks like. And then here's another view using a different layout where it's pretty much almost the same thing, but this is probably the first screen that you get to. This looks like a newer layout as well, but you can create a new job, you can set up an agent, you can configure a cloud, all that good stuff. All right, so now let's get into the Jenkins pipelines where so what exactly is Jenkins Pipelines? It's a suite of plugins that support implementing and integrating continuous delivery pipelines into Jenkins. They provide a domain-specific language, a DSL, based on Groovy, enabling users to define complex build, test, and deployment workflows as code known as pipeline as code. So if you think about it, now that I'm thinking about it, it's a little bit similar to, let's say, the GitHub Actions, where it's in code. You have the workflow in the code, and then it's going to do whatever you're specifying it to do. So this Jenkins pipeline, you're going to be writing code to say, okay, this is the command to build the application. This is the test that we're going to run upon that build. And then if all those tests pass, this is how we're going to be deploying. The application. And this is all done in code where so that code is going to be what's going to be executed when it gets triggered. Right, so pipelines can be defined in a Jenkins file stored in a version control repository alongside the project code, ensuring consistency and versioning of the pipeline configuration. They support stages, steps, and parallel execution, allowing for granular control over the CI/CD process and the ability to run multiple jobs concurrently. So like I said, this is all to support the CI/CD process so that we can be more efficient and more effective in the work that we're doing. And we can also be more confident in that the consistency in the work that we're doing is met. Jenkins pipelines offer robust error handling and conditional logic, enabling more sophisticated and reliable automation scenarios. The declarative and scripted syntax options provide flexibility, catering to both simple and advanced use cases, making Jenkins pipelines a powerful tool for managing the entire lifecycle of software delivery. Right. So, and the good thing about this is that it takes out a bunch of time being wasted, like navigating around to do a bunch of stuff manually inside the UI. A lot of times the workflows across different repos, they're going to be very similar. So you can end up setting a template of the Jenkins pipeline, and then as you move them over to different projects, different repositories, you can just make the necessary modifications and use those templates so that you can be more efficient and more effective, as I mentioned earlier. All right, so what about Jenkins and version control systems? So Jenkins integrates seamlessly with various version control systems like Git, Subversion, and Mercurial, allowing it to automatically trigger builds based on changes in the repository. It also enables Jenkins to pull the latest code, run tests, and deploy updates whenever changes are detected, ensuring continuous integration and delivery. So pretty much, that's what happens. You have a branch in Git. And then you go ahead and you make some changes. You push the code up, and that should trigger Jenkins based on your changes that you pushed up. It should trigger Jenkins to run your tests and deploy the updates. So like you say, all right, I want to merge here. And now once you go to merge, it says, okay, we have to run all these tests to make sure that we were able to merge. And if we are able to merge and the test pass, then we're going to deploy. But if something fails, then we have to raise the red flag, ring the alarm. We have to go back and say, all right, something's not right here. Let's go ahead and see what's going on. All right, so version control integration also supports branch and pull request workflows, facilitating automated testing and deployment for different branches and code review processes. So, and this is an example of the whole process, right? So over here, we have the developer who writes the code, and then they're going to go to they're going to build it from the source. So like when you push the code, all right, it runs the automated test. If there's a problem, and then it's going to go back and say, all right, developer, you screwed up, you made a mistake, go ahead and fix that. And then when you push it again, now if everything's okay after you fix it, it's going to go to the maintainer where if everything is fine, it's going to merge the code. And then once it merges the code, it says, okay, ready for deployment. And from there, you can have it decide to, all right, automatically deploy or wait for us to actually push a button to deploy. But you can configure that as you please, but it has to go through this process. If we get a problem, then it goes back to the developer. If everything is good, then we're ready for deployment. What's the next step? Put me in, coach. So Jenkins and auto builds. Jenkins automates the process of building software by pulling the latest code from version control systems and executing predefined build scripts. This automation ensures that every code change is built, tested, and validated consistently, reducing the likelihood of integration issues. Automated builds can be triggered by various events such as code commits, scheduled times, or manual initiation, following flexibility in how and when builds are executed. So, and this is something that pretty much every company, every developer, every QA person works with, right? We'll have like an event such as you commit code, you push it up. All right, let's trigger a test run, and it's gonna do like maybe testing all the unit tests every time you push code up. It might say, all right, let's run some API tests. It might say, let's run some UI tests. So that's one type of event. Another event is that we use in QA a lot is where we're not going to have a scheduled time to run unit tests, because unit tests only are affected when code changes. But we will have tests like where we say, okay, we're going to run these 100 tests at 2:00 in the morning. So by the time we get into the office, we can see the results of those test runs, and you can have so like, for instance, we have a small a subset of tests, like the most crucial tests, running daily. Sometimes they're running like twice a day, and then we have a bigger suite of tests that might be running weekly, right? It just depends how you break it down, but you have it scheduled so that you don't have to like, oh, let me go and click this button to run these tests, right? Or you can have manual initiation. So like if you need to get some particular results for whatever reason at a particular instance, you can go ahead and click a button, just run these tests now, then it's going to trigger the test and it's going to give you the results right away. It's just based on when you need it, because you might not be able to wait till 2:00 in the morning, or there might have not been any code changes to trigger it, but you need to run these tests to see if something's happening. You run the test, and then you find out right away. Sometimes, because like, for instance, if your application is connected to other APIs and you notice something weird is happening, you can click off a manual initiation, and then you get results right away, letting you know, okay, there's something that you need to look into over here, right? So it provides flexibility in how and when builds are executed. By integrating with various build tools and testing frameworks, Jenkins ensures comprehensive build and test coverage, contributing to higher code quality and faster feedback loops for developers. And that is very, very true. Like you have no idea how many times that we might end up running a particular test a day based on what we're working on. So like I've had to run the same test like maybe 10 times and maybe in a 2-hour time span, because we're trying to get results of, things that are not working the way that we wanted to. So that's definitely something that is very, very useful, and it's not limited to Jenkins. This does this in TeamCity, does it in Jenkins, it does it. You can do it in GitHub. You can probably I'm not too familiar with some of the other tools, but I'm 99.9% sure they do it as well. It's tools like Circle CI and Travis CI, things like that. So that wraps it up for today. This is part 1 of our introduction to Jenkins. So let's just go over what we spoke about today, and then we will move on to next week's, where we're going to be talking about part 2, right? So today we had a recap of the CI/CD pipelines. We spoke about what exactly is Jenkins, the Jenkins architecture. We spoke about how to set up Jenkins, which we'll be doing live tomorrow using AWS. We went over the Jenkins UI. We spoke about Jenkins pipelines. We spoke about Jenkins and version control and automated builds through Jenkins. All right. So that is it for today. Definitely, if you have any questions, if you want me to cover something more in depth, please leave me a comment. Hopefully you found that helpful and informative, and that, hopefully you found that helpful and informative. Hopefully you have a decent overview of Jenkins. There's more to go. Definitely more to go. So don't think that's it. We're going to get into part 2 next week. And if we need to have a part 3, we definitely will do that. But let me know what your thoughts are. Is there any more value I can add to you? Do me a favor on your way out though. Like the video, share the video, subscribe to the channel, hit the notification bell so you know every time that we go live and drop new content, as well as go over to techcoachrob.dev Sign up for a coaching plan. We can work one-on-one together. I can help you win. And you can also sign up to get additional exclusive content, as well as being able to call into the coaching call, message me back and forth in the Patreon, all of that good stuff. Whatever you need from me, I am here to serve you. All right. That is techcoachralph.dev, the Patreon, and we can go from there. Right. So with that being said, I'm going to get out of here. Thank you guys so much for tuning in. This is Tech Coach Ralph. We're going to run it up. You guys have a wonderful, wonderful rest of your week. We are out.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.